Hello my friends, welcome back to my channel. I am Mud Dog Sharky, and I'm back with another shaky cell phone video. This one is a very advanced topic. This video is not going to be practical for everybody. Just going to lay that on the table. This video is probably going to have very little practical information for most people. But if you build amplifiers, you've probably thought about this and never really had the time or energy or you never got around to actually doing it. So this video is going to be about automating your test bench and how to do it. Not necessarily a full tutorial, just kind of an introduction to show you some of the things that I've researched. And my day job is in automation, so a lot of this stuff came very naturally. For you guys, probably not so much. I remember my first programming language, and that took hours and hours of flipping through the books. I think my first programming language was HTML. Back in the MySpace days. Raise your hand if you remember that one. So anywho, you might have noticed I got some new toys on my test bench. I got the Siglent set up. Yeah. I am super satisfied with all this equipment going on over here. Ever since I picked up the Siglent Spectrum Analyzer, I just keep going back to their website and like, ooh, well, what should I get next? What's my new toy? So over here, I got the digital multimeter, and I got the function generator. Those are my two new additions. Hey, buddy. Yeah. What are you doing? Yeah. I'm making a video. Yeah. He just stopped in to say hello. So I keep going back to the website and checking out what's next. Well, the multimeter is freaking awesome. I've been using this crap for a long time. Yeah, this is not crap. This is very handy. But I've been using basic multimeters and simple technology for the longest time. And had I just gone out and bought a nice bench multimeter a long time ago, I probably would have broke even with all the multimeters I've thrown away. So, super stoked about that. The Siglent function generator over here is incredible, but I'm not going to go into too much detail on any particular piece of test equipment. Just know that I'm excited that I got all this stuff. And you notice the oscilloscope isn't turned on, and it's not because it's made by Rigol. It's just because I don't really have a use for programming it. And this is all plugged in through USB, and I only have so many USB ports, so... the Rigol is capable, as far as I know, is capable of doing everything. As far as connectivity to the computer, it's capable of connecting in the exact same manner with Ethernet or USB, but we'll get into that in a minute. So, the gist of this video is automating your test bench and automating measurements on whatever you want to measure. So, the reason that I'm doing this is because I want to... what's the word I'm looking for? I want to characterize my projects. So if I build an amplifier, I want to characterize that amplifier and have a record of how that amplifier performed, what parts were on it, how it was assembled, intermodulation, distortion, overall linearity, gain, harmonic output, all that good stuff. I want to have like a detailed record of that, and I want to automate that process, because getting those measurements manually can be very, very tedious, especially if you're measuring across different power levels and with different voltages going into the device and all that kind of stuff. So, I'm sure there's a few people that watch my video that, scoff at this and, they do all this automation testing and production and all that stuff in their day job. Well, I'm a hobbyist, man. This stuff is just for fun, so I'm going to walk you guys through what I got going on over here. Most of this whole automation project came about because I discovered a piece of software. Turn off that light. I discovered a piece of software called MATLAB. So I don't know how this is going to work out, but this right here is MATLAB. So I discovered this software through a friend of my friend through my day job. I saw him automating and communicating with a little prototype device that he had, and he was using this software to communicate through a serial port to talk to the device and program the device and tell it what to do next and how to perform its job and stuff like that. And I had no idea this even existed until, well, I don't know, 6 months, maybe a year ago. And this is an extremely powerful piece of software. I didn't even know what I was missing. I wish I'd known about this a long time ago. But MATLAB, basically what it is MATLAB is kind of like a programming language. But it's not just a programming language. They built an incredible amount of functionality on top of that. If you go to their website and look at their add-on modules for MATLAB, it'll boggle your mind at the speech. They do speech recognition. They have a plugin for this software that allows you to create your own VST plugins. If you guys know what VST plugins are, they basically manipulate your audio. So like if you have a digital audio workstation, you can add a VST plugin that's like a compressor. It's like building an audio rack. You put a little VST here for a compressor, maybe one down here is a parametric EQ, maybe one over here is some distortion. With this software, they have a plugin that allows you to actually create your own VST plugins and use them. So that piqued my interest among many other features of this software, but that might be very interesting for you guys that are very high up in your experimentation with hi-fi audio. Imagine building a VST plugin. That's just one plugin that does everything for your audio that you want. Like you could have a hard limiter in there, you could have a multiband compressor, you could have an EQ. You could even create an asymmetrical waveform in the same way that the motor mouth modulator does. You could create adaptive pre-distortion that takes an input signal. I'm getting off topic, but anyway, incredibly powerful software. But this video is about automating your measurement setup. So I'm going to walk you guys through some of the functionality that's included with MATLAB that allows you to talk to your test bench. And like I said, it's not just Siglent equipment. It's not just Rigol equipment. It's a whole bunch of stuff. So for example, this is a Modbus relay bank. So this is just a bank of relays, and it's controlled through a really simple serial communication interface called RS485, and the communication protocol you use over that is called Modbus. It's super duper common throughout all kinds of automation, HVAC systems, industrial equipment. Modbus is a really common communications protocol. So this MATLAB software works with that as well. And like I said, this is just a relay bank. I think there's 8 different relays in there, and you can address each one of them. So you can say, okay, I'm going to turn channel 2 off right now through the software, and it'll do it for you. You can also communicate with standard serial connections, like this little bench power supply I have here. I think it was a $100 unit, and it's got a serial port on the back. And you can talk to it and tell it to change the voltage, change the current. You can turn it on and off. You can do, all of the functionality that this power supply has. You can do that through the serial port, and MATLAB can talk to that piece of equipment and tell it what to do. So basically, let me explain what my end goal is and why I'm doing this. So my end goal is to automate my measurement process and characterize my amplifiers. Well, what that really looks like is I'll have a pallet, I'll connect power to it, and I'll be able to measure the voltage and current going into the pallet. So that's the multimeter right there. I'll be able to do that all with the multimeter. I'll be able to measure current using a current shunt. I want to be able to control the input power, and I want to be able to control the input frequency and the characteristics of the input signal. Now that's going to be the job of the function generator. So this is a dual output function generator. I think it's good up to like 40 or 50 megahertz. And this is a project all by itself, because the power that this puts out at HF frequency ranges is only about 0.06 watts. So I'm going to build a pair of amplifiers, one for this channel and one for that channel, that takes that 0.06 watts and kicks it up into the 10 or 25 watt range. So between 25 and 30 dB of gain for each one of those amplifiers. And their only job is to be a continuous carrier. So these outputs are only going to be continuous carrier. I might use this for an AM waveform generation, but mostly what I want to do is I want to use this for a two-tone IMD test. So the idea is that the signal will come out of here, and there'll be two amplifiers. So that signal will go into two amplifiers, and then the amplified signal coming out will go into a combiner. That combiner will feed the two-tone signal into the amplifier, and the spectrum analyzer will be able to read the IMD, the intermodulation distortion characteristics of that signal. So there's a lot of complexity in building those amplifiers and attenuators and isolating them from each other, and there's a whole bunch of stuff there, but that's the basic plan. And then finally, I'm going to use the spectrum analyzer to not only measure and characterize the input power, but the output power as well. So, there's that. Let's see, what have I got here? So the spectrum analyzer can only read one signal at a time. But the cool thing is I can switch signals at will. And I can program this whole system to take all of these measurements and switch all of these things all by itself. All I got to do is click one button, and everything automates and measures at different power levels. It measures input current, input voltage, input power, input frequency, input linearity. I mean, I can measure all of this stuff with one click of a button. So just for example, this only has one input signal, but I want to measure two signals. I want to measure the input to the amplifier and the output from the amplifier. So I can take a relay like this and switch the signal going into my spectrum analyzer. So one moment I'm measuring the input to the amplifier, click over, next moment I'm measuring the output of the amplifier. And I'll do that with a bird sampler slug, one on the input, one on the output. There's a few caveats to that. I got to work on signal isolation and a few different things, but controlling this relay is very simple. Controlling this with the computer and automating that process is very simple, and that's what this is here for. So this relay is gonna basically switch over that relay, NBD, pretty simple stuff. All right, let's take a brief look at MATLAB and how it works and what it can do. I apologize that I'm on a shaky cell phone video. I wish I knew how to screen capture. I'd do that. Maybe I'll figure it out one day. But for now, bear with me. Shaky cell phone video looking at a computer screen. I apologize, but hopefully it works out. But first, all right. So this is MATLAB. Right here is a program that I was working on. We don't need to pay attention to that. We're going to go up here to apps. So MATLAB as itself, it doesn't come with any of these apps. If you notice, they got an antenna designer, an RF budget analyzer, some other stuff. I haven't really played with these too much. First impression, I don't recommend them, but they might actually apply, so definitely give them a look-see. MATLAB comes by itself. The software is available for commercial use or for home use. Commercial use, it costs about $2,000. For home use, it costs about $150. I'm a home user. I'm a home gamer, so I got the budget deal. Each one of these add-ons is not free, so the instrument control is the one that we're going to be focusing on. The instrument control add-on was $45, and that's what allows us to communicate with our test equipment, and among many other things. It allows you to communicate with a whole bunch of different protocols and different stuff, but it definitely works with any decent piece of test equipment that has a GPBIP or whatever it is, GBIP port, USB port, Ethernet port, serial port. If your test equipment has any of those connections, you can 99% chance make it work with the instrument control toolbox. That's the add-on to MATLAB that allows us to communicate with this stuff. For what it's worth, MATLAB comes with a serial port connection for just like an RS-232 serial port. So, for example, in order to control this piece, this is real simple. I wouldn't need the instrument control toolbox add-on to control this with MATLAB. In fact, you can control this with there's a bunch of free programs that allow you to communicate with RS-232, but of course you don't get much functionality with them. Alright, so first thing we're going to do is pop open the instrument control toolbox. Now, these three pieces of equipment are connected to my computer with a USB port, and this is connected with an RS-485 adapter, so that's converting to RS-485, that's going into here and talking to this device. Alright, so since they're all connected under USB, we're going to go over here and take a look. And when you first fire this up, you just come down here and click the scan button, and that'll scan your USB ports and show you any compatible instruments. So these are all my Siglent items, and like I said, this works just fine with Rigol too. I just don't need it for this test, so I'm not using it. And once you get those scanned, you can pick one and you can come over here and say hello. Alright, so this is just kind of like a basic test interface. This allows you to just write some basic commands and ask some questions of your test equipment. It's just kind of a testing interface to make sure that your connection is solid and it's accepting your commands. Up here, we'll click the connect button. Connect! Okay. Now there's a lot of confusing crap on here. Data type, ASCII, data format, blah, 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 blah. In my experience, at least working with Siglent equipment, I haven't had to change any of these options. They're just correct from the get-go. I haven't had to change any of these options. It might seem like a foreign language, and it kind of is, but it all, from my testing, it all just worked right out of the box. So over here, we've got the data to write, and this is where we can run some test commands. So the commands are pretty simple. They're not ones and zeros or anything. It's not too intimidating. It's fairly plain English with, you know, some weirdness going on. So just for example, I wrote down a couple of simple things. So let's say, for example, we want our computer to be able to automate the whole process. So it's going to have to talk to the spectrum analyzer and ask a lot of questions. It's going to have to say, okay, what's our first harmonic? What's our second harmonic? Hey, spectrum analyzer, can you zoom in on this and take a reading there, and then, you know, make an average measurement? For what it's worth, every function on this machine you can control through the computer. And if you go to the website for this, or pretty much any other piece of test equipment, they have a manual that's dedicated specifically to programming it and controlling it remotely. In this case, they have a programming manual for this unit, which I think I have pulled up here. Yeah, over here. Okay, so this is the programming manual for my spectrum analyzer. And basically, it's just a big list and an instruction manual that tells you what commands are going to do what. So let's go down to the marker subsection. So for example, I've got my spectrum analyzer set up with a bunch of different markers, one at 27 megahertz, one at the second harmonic, third, fourth, fifth, sixth. And we're going to take a measurement on each one of those harmonics. Hopefully, I think I just screwed up all my measurements. So let me go back and fix that. Okay, back to normal. I forget this thing is a touchscreen. Okay, so one of the first things that I want to do is I want to measure what my primary frequency is. I want to measure the amplitude of it. I want to know how high my first marker is. So right now I've got my function generator going into the spectrum analyzer on channel 1, so let's turn that on. Okay, so this is running at 27.185 megahertz, and it's just putting a little signal into our spectrum analyzer for us to take a look at. We've got our primary frequency here, and then we've got our second harmonic and our third harmonic, and the rest of them are pretty much down below nothing. So let's take a look up here. Our primary is at 14.31 dBm, dB milliwatts. And there's a command in this list. I know it looks like a lot, but it's really not. The one that we're looking for is, where's my mouse? Is right here. So I already got that figured out. Let's go back into MATLAB and send that command and see what it says. Okay, so bear with me. I'm typing one-handed. Calc. And that is mark 1. Oops. And we want to know the y-axis. Okay, so that is the command that we need to send to ask the spectrum analyzer What's our y-axis on our first marker? So I'm going to send that as a query. And boom. We get our answer back. And it's, of course, it's in the form of scientific notation. Go figure. But what that works out to is 14.31 dBm. 14.31 dBm. And that's exactly where we're sitting. So let's take a look at our second marker. The command to ask about the second marker is equally intuitive. Instead of mark 1, we go mark 2. And we're down at minus 45.77 dBm. So if you take a look at that, that's right about where we're at, minus 45. And these measurements here are relative, so there's some math being done to them. But in reality, we're down at about minus 45 dBm. So that's an easy example for the spectrum analyzer. Let's control something else. What do we got next? Let's control the function generator. Let's do that. Okay, so over here on our function generator, that's our multimeter. Let's go to our function generator. We go through the same process, connect, data to write, and I've got a few things. One of them, one command turns the output of channel 1 on, and the other one changes the amplitude or the output voltage of channel 2. Let's try this one. Let's try turning out the channel 1 on and off with the computer. So that is C1, out P, on. And I added a colon in there when I didn't need to. Let's write that. So our channel 1 is already on. Let's try turning it off. Magically, our channel 1 is turned off. Real simple stuff. So this is just an example of some of the things that you can do with it. Let's do another example. So right now, channel 2 of the function generator is connected over here to the multimeter. And it's under remote control. Let me see if we can run stop. I didn't mess with this too much. It's under remote control right now, and I might have to mess with it a little more. But right now we've got the second channel output going over to the multimeter. That's this wire here. Output. And it's not acquiring. Can I escape out of? Oh, man. Run, stop, run, stop. Okay, well, it won't let me do it because it's under remote control. But anyway, I was going to show you how to take a measurement off of the multimeter with the voltage coming out of this. So basically we were just going to adjust the voltage out of this and measure it with the multimeter. But I screwed up somewhere along the line and disabled the front panel control. So, anywho, that's basically all you got to do to get your computer communicating back and forth with your test equipment. Now, just asking it for variables is obviously not the point of this software. The point of this software is to run a complete program with a vastly more complicated amount of functionality. So let's take a look at a program that I wrote earlier. Actually, maybe we could do a little Modbus control. Let's try and turn a relay on and off on that Modbus. Okay, so that's actually over here under the Modbus Explorer. So we're through a serial port and not over Ethernet, so we'll do Modbus serial. Reading through Modbus, again, it might look like a foreign language, but in reality, it's really not that bad. As far as digital protocols go, Modbus is one of the really easy to understand ones. Actually, I don't even know if any of this data is correct. I didn't set this up, so let's just skip the Modbus control for a minute, and I promise you, communicating with a Modbus relay like this is easy, but I'm not going to step through it on video because it's kind of a waste of time. So, obviously everything I've showed you up to this point, there's really no reason to just go in your computer and tell it to turn the function generator on, because we already got a button for that. We can just press the button and turn it on, right? The whole reason for attaching this stuff into the computer is so you can click one button and have the computer run an entire program that takes dozens, maybe hundreds of different measurements, makes adjustments in situ to your amplifier or your whatever you're testing it, rather. If you want to test something with a different input voltage, well, you can have your computer go through a series of different things, and then at some point you can have it change the voltage going into your test device, and then you can go back and measure all the different parameters of that. And that's what happens here. So let me just step you through the program real quick. If programming languages are intimidating, I understand. But in reality, they're actually fairly simple, and once you get a grasp on them, they're really not too bad. So in the beginning of this, we're just setting some things up. This whole section right here is basically just kind of setting up the Modbus and letting the giving us some basic parameters for the Modbus, the server ID, just creating a Modbus object, that sort of thing. And what's going on here is it's setting up our spectrum analyzer. So this whole chunk of code right here, that's all just basically setting up the spectrum analyzer. And thanks to MATLAB, I didn't have to write any of this code in here. It actually comes straight out of that little app that we did. I just copied and pasted this information from the app and pasted it in here, and it's handy like that. MATLAB is a really intelligent program. So some of this I did write. This chunk of code, for example, goes over to my relay and turns one of the relay coils on or off. I forget which. And then the next thing it does is it prints a command over to my spectrum analyzer and starts averaging out the measurement. So that's that line right there that says fprint. And then pause. That pauses the program for 2 seconds. And then we do a query. So this asks the spectrum analyzer, remember we did this command earlier, and it just says, okay, where is our first marker? What's the amplitude of our first marker? So it comes over here, grabs that amplitude, and it saves it into a variable. So we keep going down, it turns a relay off, pauses for half a second, takes another measurement, pauses for a couple seconds to let everything stabilize, takes another measurement, switches a relay, just really simple stuff. There's really not much going on in this program, and it doesn't take a whole lot of writing to actually get to a really functional piece of code. It's kind of an object-oriented piece of coding, like Visual Basic or any other object-oriented sort of thing. So at the end of the program, we just do a little bit of data manipulation. We remove some carriage returns and some line feeds, and just basic kind of cleaning house sort of stuff. And then we take all the data that we gathered and we add it into a spreadsheet. So I really don't think this is going to work. Now, my dumbass didn't set this up so I could click the run and show you. But basically what happens is I can click the run, it'll take a series of measurements, and then it'll save those into a file. If I click it again, it'll take another series of measurements and add those to that file. And after I'm done taking all my measurements, I can open up that file and see a log of all of the parameters that I was measuring. In this case, I was just measuring the amplitude of the input signal versus the output signal of an amplifier. And that was kind of my first project with this. But anywho, this video's gone a lot longer than I was expecting. And if any of you made it to the end of this video, well, congratulations. I hope you picked something up. To me, most of this automation stuff, like I said, it comes naturally. I've been doing it for a long time, with lots of different programming languages and lots of different formats. I've done it for lots of different reasons, but you can automate your entire test setup with some pretty simple software. It's not terribly expensive if you're a home gamer. Probably the hardest part is just understanding a programming language as it exists. You have to understand variables and strings and doubles and floats and all kinds of programming terms that, if you've never programmed before, you've never heard. Once you get over that hump, it's smooth sailing, because this MATLAB program is wonderful. It's very, very refined. And I appreciate the hell out of that. All of this test equipment is very well refined. and communicating with it with a computer is, you know, it's easy. It's no big deal. Anywho, this whole automation project, I'm going to come back and make another video once it's done, but first I got to make some amplifiers and some other stuff, and yeah, it's a work in progress. Anywho, I'm Mud Duck Sharky, and I'm back out for now. Thank you very much for watching, and I hope you enjoyed this content, especially the amp builders that watch my channel, because this stuff might actually apply to you. If you don't build amps, well, it probably doesn't apply. I'm back out for now. Take care, folks.